So today's lesson is going to be factoring trinomials. So we just finished up factoring perfect square trinomials, but not all trinomials are going to be perfect squares. So the first thing that we have to do when factoring trinomials is to make sure that they are in standard form, or in descending order. So standard form is ax squared plus bx plus c, where a, b, and c are numbers. So I want everyone to pause the video, write down these 4 problems, and to find the products. So when you've multiplied these out, the first one ends up becoming x squared plus 5x plus 6. Okay. And then the second one ends up becoming x squared minus 5x plus 6. The third one, x squared minus x minus 6. And then the last one, x squared plus x minus 6. So through looking at all 4 of these examples and looking at the factors, so what I've written in blue, what you found were products. And the questions I had you, or for each problem, these are factors that we multiplied to get us the product. So notice how they have an x in their first term. And then the last terms, they have 2 and 3. So 2 times 3 is 6. So notice what's the last term in all of these? 6. So if it was positive 2 times positive 3, we have positive 6. If it was negative 2 times negative 3, we get positive 6. So if we're looking at these first 2 examples, notice how the last terms are positive, whereas these last 2 examples, we have a negative 6. So notice how we have plus 2 and plus 3. 2 plus 3 is 5. 2 times 3 is 6. How about this next one? Negative 2 and negative 3. When you add those, you get negative 5. But negative 2 times negative 3 gets us positive 6. Positive 2, so for the next 2, positive 2 times negative 3 gets us negative 6. Or negative 2 times positive 3 gets us negative 6. But now let's add these. So if we have negative 2 and positive 2 plus a negative 3, we get negative 1. And if we have negative 2 plus 3, we get positive 1. So if you recognize the pattern, notice how we have the same thing. We have x and x, 2 and 3, but the signs are different. And so the signs are really going to dictate what this middle term is. So for the first one, it was positive 5x, then negative 5x, then negative 1, and then positive 1. And then notice how the last terms were all 6. So the question that we have to ask ourselves when we're factoring are, what are factors of the C term that add up to the B term? Or, I like this next question better, what are factors of the last term that add up to the middle term? So as we're looking at these, all of these trinomials are going to factor, and they would factor into 2 binomials. So set up your bubbles, so double bubble. And then the first terms, if we're thinking about the FOIL method, we're always multiplying our first terms together. So in order to get x squared, you need an x and an x in those binomial factors. Now, let's ask ourselves, what are factors of positive 12 that add up to positive 7? You said 4 and 3, you are correct. So, positive 4 and positive 3. So these are factors of this initial trinomial. And now to check our work, we can remultiply. So we get x squared plus 4x plus 3x plus 12. And do we get x squared plus 7x plus 12, the original problem? We do. So the factors are x plus 4 and x plus 3. So this question is very important. What are factors of the last term that add up to the middle term? So let's look at this next one. So let's write it down. And let's set up our bubbles. x and x come first because we know x times x has to give us x squared. And so now we have to ask ourselves, what are factors of negative 12 that add up to negative 1? So factors of negative 12. We can say, all right, negative 4 and positive 3, positive 4 and negative 3. We also have negative 6 and positive 2, or positive 6 and negative 2. So if we look at all of these combinations, which of these add up to negative 1? Happened to be the first one that we wrote down. So we know that x minus 4, x plus 3 are the factors of that trinomial. So let's do that same strategy for these other ones. So notice how we have 12 as the last term. I just wanted us to be consistent so we can practice with our factors. So for this one, we could set up x and x. And what are factors of positive 12 that add up to negative 8? So positive 12, factors of positive 12. So again, we can say 4 and 3, 6 and 2, negative 4, negative 3, negative 6, negative 2, 12 and 1, negative 12, negative 1. So now we need to know which of these add up to negative 8. We got 7, we got positive 8, but we need negative 8. That's negative 7. Oh, that's negative 8 here. So we know that the factors are x minus 6, x minus 2. Factors of the last term that add up to the middle term. Negative 6 times negative 2 are positive 12. Negative 6 plus negative 2 gets us negative 8. So I'm going to keep the factors here so we can practice this next one. Why don't you all try that one out by asking yourself, what are factors of negative 12 that add up to positive 4? So x plus 6, x minus 2 are factors. So these factor trees that I'm doing down here, you don't have to do those. If you know the numbers right away, you can just write out the factors. I'm perfectly fine with that. Just as we're starting to get used to it, it may be helpful for you to list the factors until you can find them a little bit quicker in your head. So let's try these without creating a factor tree, and let's see if we can just find the numbers on our own. So factors of positive 15 that add up to negative 8. So positive 15 that add to negative 8. So I'm thinking 5 and 3. 5 plus 3 gives us 8. But then we also have negative 5 and negative 3 multiply to give us positive 15. So x minus 5, x minus 3 are the factors. Let's look at this next one. Factors of positive 20 that add up to negative 9. Factors of the last term that add up to the middle term. X minus 4, x minus 5. Negative 4 times negative 5 gives us positive 20, and negative 4 plus negative 5 gives us negative 9. Okay, how about this one? So pause and try this one out on your own. So factors of negative 20 that add up to negative 8. So I'm thinking 4 and 5, that doesn't work. 4 plus 5 doesn't give us 8, it gives us 9. How about 10 and 2? So 10 minus 2 gives us 8, but we need negative 8. So how about negative 10 and positive 2? Negative 10 times positive 2 gives us negative 20, but when you add them, you get negative 8. So this one here, we have multiple variables. We have a squared, and then we also have b squared at the end. But what if I told us, what if we just forgot this b was even there? And I wrote it as a squared plus 7a plus 10. When we would factor that, we would say, all right, a times a, and then factors of 10 that add up to 7. Let's think about those. 5 and 2, so plus 5 and plus 2. But now I'm saying, all right, well, but what about if there was a b there? How would we get 10b squared if we multiplied our last terms? There would have to be a b in each of those parts. So we can just pretend like that second variable is not there and then add it in at the end, because then when we re-multiply it back to check, we get a squared plus 2ab plus 5ab plus 10b squared, which gives us a squared plus 7ab plus 10b squared. And so that's our check. So we can do that same strategy for this next problem as well. What are factors of the last term that add up to the middle term? I know I have an m and an n. And we can put an n there in the end as well because we know we have this n squared. Let's think about the numbers. What are factors of negative 18 that add up to positive 7? So we have 9n and 2n. So m plus 9n times m minus 2n are the factors. Those ones are a little bit trickier, but don't let it confuse you with this added variable within the problem.